My name is Professor Michio Kaku. I'm a professor of theoretical physics at the City College and the City University of New York. A wormhole is a gateway, a shortcut between two universes. It was first introduced by Einstein himself in 1935. Think of the looking glass of Alice. The looking glass of Alice allows you to put your hand through the looking glass and wind up on the other side of forever, into Wonderland. That looking glass is the wormhole, connecting the countryside of Oxford to this magical land called Wonderland. Well, black holes, we think, are spinning very rapidly. We see them in outer space with our telescopes, and we clock them traveling at around 1 million miles an hour around its axis. We think that these spinning black holes do not collapse to a dot. That's the old picture. That's wrong. They collapse to a ring, a rotating ring of neutrons rotating very rapidly, so rapidly it doesn't collapse onto itself. And if you put your hand through the ring, you do not die. You wind up on the other side of forever. No one has ever fallen into a black hole, so we can't test the theory. It is a theory. It hasn't been experimentally verified yet. But the theory does say that you don't necessarily die when you go through a black hole, that there's a finite probability that you can go through it and perhaps go to a different point in space and time. The catch is that to build a time machine, to build a wormhole machine, to take you to a different point in space and time, requires the energy of a black hole. You would have to have enormous energy comparable to that of a black hole to open up the gateway. And then you need negative matter and negative energy to stabilize it, which is even more exotic. So don't think that any household inventor is going to create a time machine in their basement. It doesn't work that way. We're talking about a very advanced civilization that has the capability of creating a wormhole backwards in time, or perhaps maybe to another galaxy. When you go backwards in time, the timeline forks, splits into two timelines. So Einstein said that time is a river that speeds up and slows down, that meanders its way across the universe. The new thinking is that the river of time can fork into two quantum universes. So if you go backwards in time to save Abraham Lincoln from being assassinated at the Ford Theater, you've saved somebody else's Abraham Lincoln. Your Abraham Lincoln died at the Ford Theater.
We think we had wormholes figured out on paper. So Einstein's general theory of relativity, which is our understanding of how gravity works in the universe, says that any presence of mass or energy will warp the fabric of space and time. And so you can think to yourself, imagine warping space and time in such a way that you can cut a portal from your location in space and emerge in another location in space. So these wormholes, which we can describe on paper, we don't really know how to make them. And if we did know how to make them, we wouldn't know how to keep them open. Equations show that they are unstable. You might step inside and then it would collapse down on top of you, and who knows whether that's a good thing or not. It's probably not. In Interstellar, they went into black holes and through wormholes with high confidence that they would survive. But that's where the storytelling kicks in and the physics ends. I mean, it's science fiction. So a black hole is a region of space within which light doesn't come out. Nothing comes out. If you fall in, you don't come out. But it's a hole in the three-dimensional fabric of space. So it means you can fall in from any direction. Normally when we think of a hole, like you remove a manhole cover and there's a hole in the street. You fall through the hole, you come out the other side, and you can look and see where you came out. If there's a hole in space, you fall in from any direction, you end up in another place. And if that hole connects to another place, then you have a wormhole combining the two places that you might have fallen in. And you get a black hole by a very extreme high concentration of matter. And when you have that high concentration, the gravity right in the vicinity of that continues to go up and up and up. Then it reaches this threshold where light does not escape. That's when you would call it a black hole. The sun will never be a black hole, but there's stars in the night sky that we can identify that when they die and they run out of energy to hold themselves up, the thermonuclear fusion in their core ends, and the total gravity of all the material of that star overcomes everything else that would otherwise sustain it, and it collapses down to a singularity, a black hole. So you want to avoid black holes? Really? At all cost?